Welcome to another video in the series about the C7000 compiler. This video introduces a new type named vpred. My name is George Mock and I'm your guide. In the previous video on vector comparison and predication, I ended with this example. We're going to start with it again. Anything I say now is confusing to you. The best thing to do is go watch that previous video. I want to point out a minor mistake I made. I wrote these type names without the two leading underscores. That's not wrong. You can write it without the two leading underscores, but it's more conforming to the ANSI standard for the extensions to the language, such as this type name, to be written with the two leading underscores. So I will do that in other videos going forward. So what this example does is it uses the mask bool4 intrinsic with length mod 4 as an input to create a bool vector with 4 elements, and the value that gets assigned to it, these are all the possible values of length mod 4, and this is which Boolean vector will be assigned to it as a result of that input. And you can see that the number of ones that you get matches the input. And then that's used as an input to the select intrinsic, which is selecting between values from this integer vector of 4 ints or this integer vector of 4 ints, which are all 0, choosing which of those to add to sum i4. So please focus on this type name here, bool4. I'm going to introduce a new type that can be used instead. A boolean type is a high-level type. In the previous example, it was named bool4. The representation of this type only exists at the C and C++ level, which is to say it does not exist at the hardware level, which raises the question, well then what does exist at the hardware level? Well, there's another type that you could use instead of Boolean vector type, and it's called vpred. All right, and a vpred variable models a predicate register on the C7000 CPU, which is to say it has these properties. It's 64 bits wide. Each bit controls 1 byte of a vector. So in the case of an int vector, remember ints are 32 bits wide, each 4-bit nibble corresponds to one 32-bit element. Okay, thus each of those nibbles are going to contain all 0 or 1, or if you write it in hex, it would be all 0 or all f. Here is the same example rewritten to use vpred. So here's the type name vpred. Change the variable name to m_vp for vpred. The intrinsic that's being used is mask int. It's slightly different, but it does the same thing. It's just that it returns a vpred variable. The input is the same, and so this table shows you what's happening. These are all the possible values of length mod 4, and this is what gets assigned to mvp as a result. So what really is happening is, instead of how many ones do you assign to the variable, it's how many of these f's get assigned. Okay, so 0, 1, 2, 3. Then that is used as an input to the select intrinsic. So remember, the select intrinsic is overloaded. It can take arguments of a different type, and it acts on them in, at a conceptual level in the same way. So this is doing the same thing as you were used to. These are two vectors of 4 ints, and which of these two is being added to sum i4. That aspect of things there is no different. All the changes are represented here in bold. Now that you know about vpred, when should you use it? Well, prefer Boolean vectors over vpred. They're easier to understand, easier to maintain, and so on like that. That said, there are some cases where only vpred is supported, and we will be seeing a few of those cases in the next few videos. In yet other situations where Boolean vectors are supported, it may be the case that vpred may be more efficient. But again, I'd advise you to wait for that situation to actually affect you before you go after it. There's in practice, there's probably only going to be a few situations where you'll discover that, you know, a Boolean vector is costing you a few cycles, and so going with vpred might be a way to get those cycles back. I'll close this video with two references. The first one's to the home page for the C7000 compiler. That's the full web address. If that's too much to type in, I recommend you do a search for the term C7000 compiler. All the search engines I tried, I got this result in the first two results. This is where you can download the compiler, access the manual, and more details like that. The second reference is to e2e.ti.com. This is where you go to ask questions on any TI product, including the C7000 compiler. If that question happens to be related to the compiler, it will be answered by me. Thank you for watching this video in the series about the C7000 compiler.